All right, so our next example, number 2, is our other scenario that we could use the law of cosines with. And if you look at what we're given all three sides of this triangle. So side, 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 triangle is the other instance where we can use law of cosines. And at the very end of this section, I'll talk about law of sines, law of cosines, and which instances you use each. So A, B, C. A is 5, B is 7, C is 4. Okay, so we don't have any angles, we have nothing. So law of sines is definitely out in general because we don't have any angles to work with. So the only thing I can use is I can use an alternate form of the law of cosines where you're solving for an angle. Now, it doesn't matter which one you start with. It doesn't matter which one you want to do. Don't care. Won't impact the problem whatsoever. So I'm just going to do A. I'm going to start with A, and I'm going to say cosine of angle A. And this is how I remember it. It's the sides next to A, 4 squared plus 7 squared, minus the side opposite A, squared, all over 2 times those two sides next to A. 2 times 4 times 7. All right, and like I said, I like to do the top on first and then the bottom and then do the cosine inverse because I think it minimizes mistakes. So 16 plus 49 minus 25 for all those squares. Top I get 40. And on the bottom, 2 times 4 times 7 is 56. So I get 40 over 56. 2 times 4 is 8. 8 times 7. Okay, so I'm going to do cosine inverse of 40 divided by 56. And I get 44.4 degrees. So cosine inverse of 40 over 56 is equal to 44.4 degrees. And we said that was A. All right, now we have to do it at least one more time in order to get B or C. Now we could use law of sines because you officially have a pair. But the problem is, once again, law of sines, if you're solving for an angle, you have to check for the ambiguous case. And not that it's hard, it's just annoying. So I'm going to use law of cosines again, also to help us get a little bit more familiar with it. So I'm going to do C now. It doesn't matter which one you do. Doesn't impact the problem. You could do B if you wanted. Cosine of C is equal to, so it's the sides next to C squared, so 7 squared plus 5 squared, minus side C squared, all over 2 times those sides next to C. All right. So I'm going to have 49 plus 25 minus 16 on top, 58. And on the bottom, 2 times 7 times 5, 2 times 5 is 10, times 7 is 70. So 58 over 70. And that's what I'm taking the inverse of, 58 over 70. Okay, 34.0. So I'm going to do cosine inverse of 58 over 70 is equal to 34.0 degrees, and that's equal to C. All right. Like I said, 3 significant figures. Now that we have all 3 sides, we could find we can find angle B by doing 180 minus. Now, if you find angle B using law of cosines, or if you found it in lieu of C, you might get a slightly different answer, but that's because of all the rounding we've done. So don't be like, well, how did I get a different answer? It shouldn't be off by too much, but just as a heads up, rounding does impact this a little bit. So I'll show you how that works. So if I find angle B, it's going to be 180 minus 44.4 plus 34. So 180 minus 44.4 plus 34. So if I do it that way, I get B is 101.6 degrees. And that's totally cool. Like, we're good. I'm good with that. You can tell me that's your answer, and that's great. But I'm going to do law of cosines just so you guys can see it again and to show you where we might get a little bit of a discrepancy. So cosine of B, it's going to be the sides next to B squared minus side B over 2 times those sides next to B. So 4 squared plus 5 squared minus 7 squared, 2 times 4 times 5. Okay, so 16 plus 25 minus 49. On top I have negative 8. And on the bottom, 2 times 5 times 4, that's going to be 40. So negative 8 over 40, or 1/5, negative 1/5. Okay, do cosine inverse of that. 101.53. So let me write this down. Negative 8 over 40, I get 101.5 degrees. Now, we're not off by a whole lot, but that has to do with how we've rounded A and C. So I just wanted to give you a heads up that if you're going through it, or if you're going through the homework and I do it a little bit differently than you do it, and you're like, God, I'm off by like a decimal, or I'm off only by a little bit, it's just because of how we've rounded in the previous pieces, and then with that angle B, we just kind of took our shortcut. If we'd found the actual cosine of B, we would get our actual angle. And the more decimal places we carry, obviously the more accurate this will be.